After you understood how to find the gradient at a tangent, the next step is to actually find the equation of that tangent. And we also take it a step further and we find the equation of the normal. So just to do a quick recap, if I have an equation, so a linear equation, 3x plus 4, for example, this is in the form of y equals mx plus c. And if I want to find the normal, which by definition is a perpendicular line to the normal is perpendicular to your line, so it forms a 90 degrees. Then if you notice the link between the gradients of the normal, so the normal becomes a negative reciprocal, so a negative reciprocal. And that's an informally, I can say that you change the sign and you flip it. So that's an informal way of saying a negative reciprocal. So if it was negative, it would change to a positive. If it was a 1 over 3, it would change to a 3, for example. So negative reciprocal, or flip and change change the sign. So the normal just forms this 90 degrees. Now the c can be completely different for the normal and the gradient. It doesn't have to be the same. It's just a coincidence that it is in this example. So how does this help with calculus? So if I have, let's say, a curve and it touches this green line. So let's say my green line is the tangent at my point 0 here. So that's my, so the green will be the tangent at the point. And then I could find the gradient of this tangent by first deriving my red function. So I could derive the red function and then substitute the x that I need. So the x I can take from here, so that's 0. And then that would give me the gradient of the green function, which is the green tangent line, which is, in this case, is 3. And then if I want to find the normal, I'll just follow the negative reciprocal and I'll get the gradient of the normal line. Now, what we're going to do in this video is actually find the full equation of the line. You should know how to find the gradients of the tangent because it's just a derive and substitute method. So just to summarize, the equation of the tangent, let's say you have your coordinates a, b, where I'm going to call them a, b instead of x and y. The gradient m is found using the derivative, and then the normal is just a negative reciprocal. And then you can either write it in the full form or the y equals mx plus c form. So you'll have to find the c, that you'll have to go through the process of finding the c. You're going to do the exact same process for the normal. And then sometimes we write the equations in general form where a, b, and c are numbers, but more specifically, they are integers. So they're specifically integers. So the idea is that the process of finding the gradients will be different for the tangents and normal, but the rest of the steps are quite similar. And if you want even more details about the tangent and the normal, there are other videos on these. So I'm going to go through one example of how to do the full thing. So if I have this function, and the first question is find the derivative at x equals to 1. So the first step is to derive. So I'm going to do the derivative of prime of x, and that's going to be 6x. And then I'm going to substitute my x. So I'm going to put my x in there, and that's going to give me 6. So next, I need the equation of the tangent. So keep in mind that this 6 is it's the gradient of the tangent at x equals to 1. So when I'm trying to find the equation of the tangent, I already have the gradient. I have my m in this case. So if I have the y equals mx plus c, this will be the equation of the curve at x equals to 1. So if I have my curve here, this is a quadratic, and this is my 1. So if I have my tangent here, this tangent, I need to find the y equals mx plus c. I already have the gradient of it, which is 6. Now, in order to find c, the process is to be able to substitute. One method is to substitute a coordinate you already have. So if I can fit in an x and y that I already know belongs on this line, then I'm able to find c in order to complete this whole form. So what coordinate fits in this line? Well, I know that x equals to 1 has to belong on this tangent because by definition, this tangent touches my x equals to 1. But what is the y value? Well, here's where students forget the simplest part of functions is that if you have the x value, to find the y value, just substitute in the original. So I just want to know this coordinates here. Yes, it's x equals to 1, but what is the y equal to as well? Because this point also belongs on my tangent line. So I'm going to substitute 1 in my original function. So f of 1 is equal to 3, 1 squared minus 2, and that's equal to 1, which means this coordinate is 1. It belongs on the curve and it belongs on the tangent line. So I'm just going to substitute it in here. And then when I solve it, I'm going to get c, which is equal to negative 5. Great. Then my final answer is y equals to 6x minus 5. Do not leave it with the x and y substituted, because that's just the coordinate of 1, 1 is just a point on that equation. So the question just wants the equation of the tangent, which is this. Now we'll do the same thing for the normal, except that the first step is going to be a bit different, where we will find the gradient of the normal. So the gradient of the normal is a negative reciprocal. So if the gradient was 6, so a negative, I'm going to change the sign, and then a reciprocal, that's going to be 1 over 6. More details about a reciprocal: if for example, the gradient was 2 over 3, then the reciprocal will be 3 over 2. So now that I have this, I'm going to follow the exact same step, put it in here, negative 1 over 6, and keep in mind, even though it's the normal, even though it goes 90 degrees to my tangent, so if I do this blue for the normal, it still crosses this coordinate of 1, 1, so it's still my 1, 1. Okay, so the normal still goes in there. So the coordinates 1, 1, I can still substitute in this and find the c. So I'll substitute in there, and c is equal to 7 over 6, which means my final equation is just negative 1 over 6x plus 7 over 6. So it's quite an easy process. It is made simpler by the fact that you know derivatives, so you can find the gradient quite easily. So another example is to do things with what we call horizontal tangents, which we will use heavily in later on when we're doing stationary points and so on. So a horizontal tangent is just a straight line. It's a straight equation, and horizontal lines have a gradient of 0. So this is a fact you need to remember. And they look like something y equals to c, and c could be any number. So this is something you'd have to remember. Now, if something has a gradient of 0, let's link back to calculus. It means that if I derive my function, this is the derivative of y, so dy by dx, it means, and this is the gradient function, it means that the gradient function has to be equal to 0. So once I've established it's equal to 0, I can now try and solve it. So I need to know which x would give me a gradient of 0. These x won't give me a 0 for the y value, they'd only give me a 0 for the gradients, which is what I need. Okay, so I'm going to solve this. I'm going to actually simplify it, divide by 6 everywhere, factorize it if you can. If it's a more complicated one, just use the quadratic formula, and then it will give me x equals to negative 2 or x equals to 1. Now, if I look at this curve, this is the curve of the original function, so this is actually y. And if I see at precisely 1 and precisely negative 2, so these are where my points are. And you can imagine a tangent going through them being horizontal, and that's what we need precisely. So we're going to, we need the actual equation of the horizontal tangent. So this is not enough. The horizontal tangent is not x equals to 2. Remember, it's the y equals to something. So what we need to do is actually find the y coordinate at 1, and we need the y coordinate at x equals to negative 2. So how do we find the y coordinate? Remember, we just substitute in the original. So at x equals to negative 2, y equals to 21, you can use your GDC or just substitute directly in the y. And when x equals to 1, y equals to negative 6. So the final answer is that the equations of the horizontal tangents are y equals to 21 and y equals to negative 6. And this is my y equals to negative 6, and this is my y equals to 21. I would recommend you watch this part again from the beginning now that you know where we're heading, so that you understand why I explained the gradient equal to 0 and the form and so on. So this is the type of horizontal tangent we're going to look at, but they're also called, these points, the negative 2 and 1, are called stationary points, so they're quite special. But it's important to remember that they have horizontal tangents, and these tangents have a gradient of 0.